Okay, so let's start. First of all, thank you all for being here. Here in Lübeck we have many initiatives to drive ecologically, for example, e-car sharing or electrical buses. But in Travemünde we have ships, or worldwide we have lots of ships. And one question for you guys, or just for you to think about, how much CO2 emissions do these ships worldwide actually emit? And the answer is actually around 3%. And that may not sound like a lot in comparison to the 20% which is emitted by road transportation. But with globalization and with increased economic growth, we can see here in these models which were conducted by the International Maritime Organization, that the climate goals set by the Paris Climate Accord of 1.6 degrees maximum global temperature increase are indeed in danger if we do not create the right interventions. The International Maritime Organization, with the MARPOL Annex 6, has had some attempts to work on this, for example, improving the way we build ships, or how we adopt behavior on board of ships, or how we even track energy efficiency. Energy efficiency, by the way, of course, refers to going the same distance, carrying the same amount of cargo, but using less fuel. And however, these measures have not achieved the expected results so far, but this is something which is not uncommon in many industries, which is common in many industries, and is often referred to the energy efficiency gap. And one way in which we can bridge this gap is, and as we engineering psychologists know, is that energy efficiency is always technical potential times human behavior. And this is exactly the objective of my research here. How can we use human behavior to increase energy efficiency on board? And there is actually very little research done in this area, but some indications that it is actually a very viable avenue of research. For example, this one study conducted by Jensen and colleagues shows that just by raising awareness, we can have fuel consumption decreases of roughly 10%. So in the next steps, I just want to show you two papers from human factors research, mostly focused in road transportation, but which we can use to apply in maritime shipping. So this was a paper from Franke and colleagues from 2016, and which describes a control theoretical framework. And this allows us to better understand decision making under uncertainty, or when adapting to environmental dynamics. So the system variables, these up here, are of particular interest to us, because these variables describe the driver, or in our case, the crew. And while there are quite a few of these variables up top, we can summarize them with four categories. We have strategies, we have knowledge, we have motivation, and we also have implementation. And these four categories will be informing my future work. Another staple of human factors research is mental models. A mental model is a mental representation of a system, and it allows a user to predict the outcome of a system interaction. However, in shipping, one challenge is that mental models, comparing mental models between different crew members can actually be quite difficult. Because first of all, they may be using different engine types, that is, they may be using different systems, or they may be using, they may have, even though they have the same rank and the same role, they may have different responsibilities depending on the ship, so they may have a different kind of interaction. So how we overcome this challenge, we will get on that point later. So taking these previous work into consideration, we formulate four objectives for the study. First of all, just assessing, like a baseline, what is the current research level and what do we need in the future. How can we determine which criteria influence the decision for energy efficient behavior? And thirdly, how can we predict mental models? And finally, what are the suggestions for educational or technical systems which can improve energy efficient operations, or EEO? To answer these questions, I conducted three studies. First of all, a systematic literature research, then an onboard interview, which built upon the findings of the first study, and building upon that, I conducted thirdly an online survey. So let's begin with the first part, the first study, a systematic literature review, which seeks to answer the first research question. So, using this search term and snowballing thereafter, I cited around 700 results, of which 10 were of particular interest to this paper. I found that of these papers, generally the authors tried to find a framework to understand EEO on board, or looked at educational methods to improve EEO. Also of interest were studies in general of the role of human factors, for example, collaborative learning or distributed cognition, so in a broader sense, teamwork. However, one criticism I have of these works is that they mainly focus on only one department, so for example, only the bridge and not the engine room, or they only focused on one shipping company, which may result in or there may be differences in shipping company policy or just the culture which is inherent in that company. So to go even further in depth, I contacted the authors of these papers. Two of them replied to me via email, and another two I conducted telephone interviews of around 30 to 45 minutes. And then, just in these interviews, I further found that the complexity of the environment was a very big factor for a key learning from their research, and that there are many different levels of understanding inside of the ship and with the communications with external stakeholders. And as the open questions remain, what are the interventions which can help EEO? So the implications for this work, just as a takeaway, mental models is a novel research approach which hasn't been used yet, and in order to accommodate the complexities of shipping, we need to conduct research in the entire ship and from multiple shipping companies. Okay. In the next step, we work with a shipping company in Onboard to find answers on the criteria influencing decisions on board. I went on board a ship in the North Sea for approximately a week, and I conducted interviews with the entire crew, each lasting around 45 minutes each, giving us around 11 hours of interview material. I used a interview guideline which built upon previous work and which had the main focus of describing or finding energy efficient situations and describing how and what for. And to do this, I used the BPMN, the business process model and notation system, which allows the visualization of start and end points, interactions, decisions made on board, and communication. And while I was conducting the interviews with the crew members, I created a model of each situation in tandem, so this gave us a further structure to our interviews. After I transcribed, I used a smart transcription method. I analyzed this data with the mapping analysis in the sense of Brown and Clark in their paper from 2006. We're mainly using a data and theory, well, using both a data and theory approach. So with the data that is looking at reoccurring patterns, and with the theory-driven approach, taking, for example, these four elements from the control theoretical framework, which I mentioned earlier, to find similar elements in the work. In general, I used a semantic level analysis. I did not interpret much because this is the day-to-day work of the seafarers, and this is also another reason why. This is a reason why I did not retest the variables. So I did not have a second rater, which should be taken into account. This is the reliability. Yes, so in the end, I extracted four themes, which I will now present to you. The first theme is strain. The first theme, strain, refers to the day-to-day burden which all crew members are exposed to and may actually present a barrier to EEOs. So, strain may include concerns about safety. In this quotation, we have a bridge officer referring to four safety concerns: that of the crew, that of the ship, that of the cargo, and finally that of the environment. Another thing which is actually quite interesting in this quote is that the crew member mentions one way in which he learned this, that is in interaction with a superior officer, which you should take note of. Another important factor of strain is workload. Here we have somebody who says he has not slept for 2 days. Maybe hyperbole, but but generally it should be noted that sleep deprivation is not good for non-critical behavior such as energy efficiency. And finally, uncertainty. Here we have a situation where the crew was not able to tell, can I now go fast or slow, can I use eco speed or not? And this lack of being able to predict outcomes, or generally in this uncertainty, can hinder situational awareness. Okay, let's move on to the second theme, and this is just in general strategies. So what are the knowledge about behaviors which can improve energy efficiency? And everyone on board mentioned around 1 or 2 strategies, and here we have the top 6 strategies which were mentioned. And we can see on number 1 is actually the reduction of usage of appliances or light. And now this is actually quite interesting because when speaking to certain crew members, it became quite clear that when traveling underway, also when traveling at sea, electricity is generated from the motor of the engine, who's using the shaft generator. So the actual impact of turning off the light is close to 0. And this is actually, so this is a very prominent false belief, but it also suggests that energy efficiency or knowledge on energy efficiency is not always gained from training or from seminars, but rather mental models are used which are learned in other contexts. For example, at home, and then I apply my mental model of home electricity and apply it to the ship. So the third theme is influence, and this refers to when a crew member may actually be motivated or have knowledge about energy efficient operations, but may feel hindered by external stakeholders. And the most often mentioned here was the charterer. So that is the person who pays the shipping company. Here, please transport this from Hamburg to Rotterdam. And they often have deadlines. And these deadlines go hand in hand with here increased speed. But sometimes the language which is used, here for example, go out of limit, is actually not something which is possible. So we have here a difference in knowledge between different stakeholders, and that could be a source of conflict. Here, typical seaman, no, lots of swearing, fulfills every cliche. But not only speed, we also have fuel as a concern. And now fuel is interesting because it speaks directly to the principal-agent problem. That is, that different people, different stakeholders have different responsibilities on board. So if a company wants to be energy efficient, it also has to work, or it cannot work, with a charterer who is not energy efficient. So the fourth mental model, the fourth theme is motivators. And this is behavior which could increase the likelihood of energy efficiency. And the most common mentioned motivator was actually the shipping company. And this could be either in a sense of, or an extrinsic sense, just as this quotation refers to job security, but it could also be an intrinsic sense. For example, the company does good by me, I'm going to do good by the company. And another interesting factor, which is another motivating factor, is secondary benefits. So, for example, conducting maintenance on the engine is something which has to be done anyway, but good maintenance actually improves energy efficiency and reduces consumption. So this suggests that energy efficiency can easily be combined with other already existing activities on board. Okay, so going forward, I want to take the final two themes and further analyze them, have them rated in a large sample, and then try to find an underlying structure using an external factor analysis. And this will be done in part 3, which was done in part 3, an online study which focused on a very diverse sample. And to get this diverse sample, I conducted an online survey by recruiting from mailing lists, from the shipping companies, Facebook, Reddit, and so on, but also working with a course of studies in Flensburg, nautical students. And these participants were asked an array of questions. First of all, the rating of the factors of the motivators and influence, and also a self-report of the motivation to behave energy efficiently. These questions on mental models and knowledge I will get to in a second. And qualitative survey questions, just open questions on what they think, what interventions could be useful. So having a look at the first subject, motivators, we have here a row of motivators, or sometimes anti-motivators. No? So we have those factors in theme 4, which increase the likelihood of energy efficiency, but also decrease the likelihood. For example, missing knowledge. Participants were asked to rate how much these motivated or hindered energy efficiency, and then I conducted an explorative factor analysis to identify an underlying structure. I used for each factor, each item which had a factor loading higher than 0.5 was included, or in the case of environment, I selected the largest loaded item. The first factor, company, which is in line with the motivator I found in the interviews, had explained around 1/4 of the variance. The second factor, the work or the strain factor, were actually just task-related workload on board of the ship. The third factor was an inverted item, which is probably those people or those observations who are not motivated by a reduced workload. This possibly being crew members on the bridge who could actually not relate or could not see the advantages of maintenance directly. And finally, environment with one item. I think that's self-explanatory. Just as a quick note on the side, orders from the charterer was actually the most highly rated, just from a descriptive level, the most highly rated hindrance of all the others. And now just a quick fun fact as well, the general motivation to behave energy efficiently can actually be predicted by higher levels of concern for the environment and lower feelings of hindrance by missing knowledge. So my second factor analysis on the influence theme, here we have ratings of perceived influence. So for example, how much do the decisions of the charterer influence energy efficiency on board? 1/3 of the variance was explained by external stakeholders, and this once again is in line with many of the interviewees and their perception that they have no control. The second factor included was the master as well as the participants' actions, and this factor actually correlated highly with higher ranks. So this could actually be interpreted as being the factor of seniority. The higher the rank, the greater the influence on energy efficiency. And here the rest of the ship. This was a factor which was rated highly by lower ranking members, perhaps the naivety or the less experienced wish list. And here the fun fact, the external factor correlated with the means of the hindering factors we saw on which we saw on the last slide correlated. The external factor here correlated with the hindering factors scale, that is all of the anti-motivators, and this means, or this can be interpreted as meaning that those who felt a strong influence from external stakeholders also felt more hindered by time, safety, and knowledge constraints on board. Okay, just a quick word on mental models. Here we used an indirect method adapted from Franke and Krems in 2013. We described two situations and asked the participant to predict how much energy can be saved in this situation by using the energy efficient operation described here. We then asked them to predict their confidence in this value. And this confidence is actually the most important question. We did not look at the first question, actually. And this helps us, and the reasoning behind this is that if you have a better mental model, you can better predict outcomes. So you have a higher confidence in your predictions. To validate this, we also self-reported knowledge in each domain. So here this is pertaining to weather, this is also pertaining to weather. So we found high correlations, we also found a good item, or we found an acceptable item difficulty and item discrimination, so we assume that it was a reliable method. For our regression analysis, which included also members of the crew, not just our online sample, we found that only knowledge was a significant predictor of mental models. The other factors, motivation and rank, these taken from the control theoretical framework, were not significant, were not found to be significant predictors in the significant model that we found. Okay, so the last question which we asked the participants was the two open questions, which were then sorted into in vivo codes, which were then categorized. Regarding technology, we most often mentioned were navigational aids, which actually makes sense because around 70% of the fuel consumed on board actually goes to propulsion. We also see the recurring theme here, the wish for reduced framework, for example, through automation. And regarding what seafarers need to learn, ship functions and navigation are most common, and I would suggest that this is, in a way, also saying that crew members want better mental models. Okay, that was a lot. I'm just going to do a quick recap, talk about the implications and the limitations, and come to an end. So, I did a literature study which showed that EEOs were as a complex subject and needs better interventions. In my interviews and online studies, I disseminated decision-making criteria into 4 themes and further split them up into smaller factors. I found that knowledge was a predictor of mental models, and that navigational aids were often asked for, as well as technologies which could reduce strain and workload. I take 3 implications from this work. The first of which is that a control theoretical framework can be used to understand how external stakeholders set the boundaries in which EEO is possible. So it could also explain if, for example, if a crew who was knowledgeable and motivated actually acquires a kind of learned helplessness in its implementation. Secondly, the dissemination of knowledge is important and often happens on board rather than in the classroom. So, using institutions which are already in place, such as the weekly safety meetings, we can spread knowledge and at the same time not increase the workload by too much. And on the subject of workload, reducing workload increases the capacity for energy efficient operations, and this can be done, for example, by using simplified interfaces or by improving communications, reducing uncertainty. And especially by working with the shipping company, we can use the advantage which was suggested in the motivators. To our limitations, first of all, the sample size which we used for the exploratory factor analysis was, we tested with the KMO criteria, and this was acceptable. However, some literature sets out sample sizes of around 300 for factor analysis, so that's something to be aware of. Secondly, because of our cooperation with the University of Flensburg, we had a large amount of cadets. So this could be, so this over-representation of the lower ranks could mean that we are skewed, we are slightly skewed towards people who have more theoretical or more present theoretical knowledge and less work experience. And finally, we did an exploratory study. This is mainly pertaining to the other work in the manuscript, and here I used the Bonferroni-Holm correction to account for the alpha failure, but still there may be some better errors caused by the conservative nature of these tests. And finally, for further research, I suggest the experimental research on strain, especially with the use of simulators. Secondly, developing methods to better ascertain mental models, and not just task mental models, but also team mental models. And finally, improved interface or increased interface research, especially for the engine room, which is often overlooked as a source of as a point of research. So, here's just an overview, which we can have a look on in a second, but otherwise, I thank you very much for your attention.